I'm so excited that I'm cool now. That's awesome. So hello, everybody. As you've heard, I'm Melanie. I'm a web designer and front-end developer on the Microsoft Edge team. And I'm so excited to be talking with you today about CSS Grid, which will be in public builds of Microsoft Edge starting next month, October 2017. So among other things on the Microsoft Edge team, I work on web properties that help us communicate with web developers such as yourselves, and as well bring in your feedback to inform Edge HTML. So to give you a little bit of context into my background, I studied graphic design in college. So this is a more traditional graphic design program, branding and print, things like that. But I actually ended up specializing in web after school. I did plenty of web projects at a small design agency. I can't actually tell you how many because I don't know. It's just so many. So it might not make sense that I specialize in web design, but I actually did quite a few personal web pages over the years. So my first website was created when this aesthetic was perhaps appropriate, maybe. So you can imagine I've run the gamut on layout techniques over the years. So this was built in around 2000, 2001, which is an important time for front-end web development. So in 2000, IE5 became the first browser to fully support the CSS1 specification, which brought more styling to the web. So out in the wild, you kind of had a blend of table-based layout and CSS-based layout. With table-based layout, we had, crufty, heavily nested code, perhaps not the right semantics for our content. We would later on have CSS properties that would emulate these layout techniques with other elements, but that wouldn't be for a while in the future. But so the CSS1 specification introduced a paradigm from desktop publishing called floats. If anybody can't see the slides, I'm using adorable dogs to demonstrate CSS properties. So basically, a float in desktop publishing is where you had a piece of media, such as an image, and a run of text that wrapped around and below it. And so we web developers took one look at this CSS feature and went, you know what? I can make a print-like grid out of that. So that's what we've used it for quite a bit. This is perhaps not the most appropriate use of floats, or maybe not as how it was designed. So we've kind of run into some issues, such as having to clear our floats. Another strategy I've used to get siblings next to each other is display inline block, but this has its own problems too. I've gotten quite a few headaches from subpixel rounding. So you apply, a percentage to an element, and it gets computed to a fractional pixel, and then different browsers will round that different ways, and suddenly your layout is broken. More importantly, these are not block boxes, which means that any spaces in your markup between the siblings is going to be treated as flow text, which means that you might find some spacing in your layout that you didn't expect to be there, and you're like, why is this here? This is also not a fully fledged layout feature, so we can't do certain things without JavaScript, such as having equalized content-based heights. Another strategy we've used to create masonry Pinterest board-like layouts is multi-column. And I admit it, I've used position absolute to redistribute content without changing the markup. Show of hands, who's done it? All right. So basically, where there's a will, there's a way to write some hacky code. One powerful solution that has emerged to solve some of these problems is Flexbox. So with Flexbox, we have a main axis, which can be either row or column-oriented, but for the sake of example, let's just say rows. And we can tell elements how to consume space and distribute themselves within this main axis. We can also redistribute content without changing the markup, although we have to be careful about accessibility here. We do have a cross-axis, which is perpendicular to the main, but we have far less control here. All we can really do is distribute items across this cross-axis. We don't have the same kind of sizing or placement control as we do in the main, and we can't redistribute in the same way as we can with the main axis. So while Flexbox is a powerful layout feature that is still really useful today for quite a few use cases, it doesn't necessarily cover everything. So we can also wrap new elements onto new rows as we run out of space, but we can't do really precise placement or creation of new rows. So as I said, it doesn't really cover everything, but it does cover quite a lot. So this brings us to CSS Grid. So Microsoft initially proposed CSS Grid in the W3C CSS Working Group as a solution to truly two-dimensional layout. So Greg is going to give you a little bit more of the history behind CSS Grid later on today. But basically, we in the web community needed a layout tool that can do true sizing and placement in 2 dimensions, so rows and columns. So with CSS Grid, we can create truly polished, precise layouts where things line up just so, and elements are relationally sized, and we have greater symmetry and consistency across the layout. This is great for our fussy perfectionist side. And we can also make more creative use of 2-dimensional space, which is great for our artistic side. Sometimes these are the same side. As an added bonus, we can also overlap grid items, which is something that flex items can't actually do. So for example, I was working on the Summit website this year, and I was like, let's play around with CSS Grid. And I was able to have like this row at the bottom that left some space open for a fixed position nav. There's a couple items that are proportionally sized to each other, and then the rest of the viewport is taken up by this banner image. Now this is something we could probably do with other layout techniques, but we might need more wrappers or more code. I was just so amazed by how few lines of CSS I could achieve this in without extra wrappers. So I was like, oh my gosh, CSS Grid is so cool, and like ran around the open office at work telling everybody how cool it was, and then got on Twitter and was like, oh my gosh, this is magic. So CSS Grid is magic, but how does it actually work? So Grid is what we like to call a top-down layout approach, or as I like to think about it, it's kind of like a parent laying down the rules and telling the children what to do, and those children kind of have to follow those rules. So let's kind of step through what it takes to create a grid layout. So first, we initialize a grid formatting context by placing display grid or inline grid onto a parent element. We then define the grid via the parent's properties. So these are the rules that we're talking about. There's quite a few different properties here, and there are so many different ways to express the same grid with these various properties. So we're kind of going to be scratching the surface, and we might not go into all the shorthands today, but this is what you'll kind of take a look at as you explore more. So when we define a grid, we create what are called tracks, which is a cumulative name for rows, as well as columns. So we got 4 and 3 in there. When we create tracks, we create 2 grid lines per track, a start and an end value. Sometimes these are synonymous with the edges of the grid themselves. You can also name lines, but we won't be getting into that today. We can also create grid template areas, which span both rows and columns and make it easier to place elements into the grid because it controls both sizing and placement at the same time. So once we've created the rules of our grid, we then place the children into this grid. So we have a suite of properties that we can use to place those children in there. And we can also tell these children how to align themselves within the slot. So if we don't want it to take up the entire slot, for example, we can move it to one side or another. So a slot is the name for the cells that are created by the overlapping intersections of rows and columns. So there's some justify and align properties that come up quite a bit in both Flexbox and Grid, and I tend to kind of get these confused, so let's kind of go over that really quickly. So in a horizontal writing mode, such as an English web document, the justify properties are going to be horizontal, and the align properties are going to be vertical. The way I like to think about this is in desktop publishing, you might have left justified or right justified text, and the justify properties are flowing in the direction of the text. So when we have a vertical writing mode, for example, these are reversed. So you have vertical text, and you have justify properties in that direction. This is something you would use for perhaps Chinese or Japanese text. But we won't be getting into writing modes today because that's a whole other CSS feature. So now that we've placed items into the grid, we just have to size and distribute that grid. So we have a couple properties that we can use to create gaps in between tracks. And we can justify and align items, which means we tell the items how to distribute themselves in both axes. And we can also take the grid content as an entire unit and tell it how to justify and align itself within whatever grandparent element it may be sitting in. So now that we have the lay of the land, it's quite a lot, let's go through a basic example with explicit placement. So let's say that we have this layout where we have two sidebars of a specific width, and then we have a column in the middle that we want to kind of expand to fill that space. And then in the third sidebar, we have 3 boxes of equal height, and then all of these columns are equal height as well. So our markup for this is going to be very simple, actually, just a parent and some child items. So there's no wrappers involved here, nothing like that. So first we establish our grid formatting context, as I mentioned, on the parent, so display grid. And then we create columns. So how we do this is we set our grid template columns property, and we're setting this to 22M, 1FR, 22M. This 1FR unit might be a little bit new to you. So this is basically a unit that tells an element how to proportionally take up space after the items of definite size are placed into the grid. So you can think of this as being like the width of the grid minus 44M. If we had 2 columns in the middle here of 2FR, 1FR, then the first of these 2 columns would take up twice as much space as the second. We then add our grid template rows. So here we have 1FR, 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 because we wanted those 3 boxes in the right-hand sidebar to be of equal height. And this can also be expressed with the repeat function. So we have repeat 3, 1FR. That first digit is how many times this structure should repeat, and we can have some other functions in there too, as you'll see later. And the second is what is the measurement of that repeating row there. We then apply our grid gap, so 1.5M. If we wanted to, we could actually have different measurements for the gaps between rows and columns. And whenever you're using shorthands in grid, the rows come first. So we have our grid established. So let's place some items into it. So we place our first child in there using grid row 1/span 3. And what this span 3 does is it tells it to span 3 rows. Otherwise, we'd have some really tall rows because, again, equal height. We also place it into grid column 1. We don't necessarily actually have to do that because the grid is smart enough to kind of auto-place things often, but just to be explicit, let's add it in there. We did the same thing for the second child, so we put it into grid column 2 instead. And then we place our elements into the third sidebar. You'll notice there's no spanning here. Automatically, you're just going to span one row or column. And you may have noticed when I added that third element into the grid that everything kind of got a little bit larger because, again, equal height rows. So I want to pause here for a second because there's something that might not be super obvious as I go through these examples, which is that I have some base CSS running on the demos where a max width of 100% and a height of auto is set to images. This is because sometimes elements with intrinsic sizes, such as images, can cause some unexpected results in a grid. So for example, in this example, so we have 1FR. What this actually means is a minimum of auto in 1FR. So if this image was 2,000 pixels wide, and we didn't have that CSS applied on here, this middle column would be a minimum of 2,000 pixels wide. So not what we expected, right? So we just have to have that CSS on there. Sometimes we might want a grid that's based on the intrinsic sizes of our elements, but not always. So it's just something for you to keep in mind. Other elements that have intrinsic sizes include video, audio, canvas, and form controls. So now that we have rows and columns down, let's quickly cover grid areas. So we create some rows here, and we create some columns. And now for the grid areas, we have to kind of create like an ASCII art representation of our grid. So we're using the grid template areas property. And for each row, we have a new line of CSS code, and it's wrapped in quotes. And space separated, there are values for each of the slots within this row. So in this particular example, we have logo nav nav, side side main, side side social, and foot foot foot. And this might be a little weird when you first look at it, but what it basically renders is a few different grid areas that we can use. So we have a slot called logo that is just the intersection of the first row and the first column. And then the rest of that first row is nav. Then we have a side that takes up the first column and the second two rows. And next to that, main and a social area. And across the entire bottom row of this grid, we have a foot area. So what we can then do is place our elements simply into this grid using something like, for example, our logo goes into grid-area logo. So those are a couple examples with explicit placement. But let's say that we don't want to always take each and every single grid element and place it into the grid on its own. And we might not actually know how much content we have. So luckily, Grid can handle implicit placement. So to take a practical example, let's say that we're building a blog for Contoso Kennel, and we have this, like this layout where we want some thumbnails for each of our blog posts to be a certain width, and just put as many of those as we can in a row and wrap them to new rows when there's no more space. So how do we do this? We set our grid template columns to, this is kind of a beast, repeat, auto-fit, comma, min-max, 12m, comma, 1fr. So let's kind of wrap our heads around that beast of a value there. So we're using the repeat function, and inside there we have auto-fit, so we're telling our grid, hey, fit as many columns as you can of a particular measurement. And that particular measurement is the minimum of 12m and 1fr. So basically what this means in this example is that everything's going to be sized to 12m, and if there's any space left over in the grid, they'll expand equally to take up that space. So you see we kind of change the width of our browser, and automatically we have a grid that still fits within the space elegantly. So we have 4 columns here instead of 6 in the previously wider browser space. So let's say that we actually don't want the items to expand to fill the grid. We just want them to be 12m all the time. So we change that value. But now we have space on either side of the grid. So we can actually decide how we want to consume that space. So right now we have the items justify item center. But we could also do justify item space between. And that will take that extra space and put them evenly in between the items. It's like what it says on the tin. So let's say that we're using this example, and we actually have fewer elements than can fit in a row. So the grid is a little bit narrower in this example. This is because autofit, as it tries to place items into the grid, if there's any empty tracks in that row axis, they will be collapsed. So the grid is narrower. But let's say that we're actually making a paginated blog index, and we want the layout to be exactly the same from page to page, no matter how much content is there. So we can change this to autofill instead. And the key difference here is that autofill does not collapse empty grid tracks. So you'll just have a couple empty grid tracks just hanging out there on the side, and the layout is consistent. We can also blend explicit and auto tracks. So let's say we have this photo album example here, and the first few rows are heavily art directed. We know exactly where we want things to go. And then after that, we kind of just want the rest of the elements to flow into auto rows of a particular height. So the cool thing about CSS Grid is we can actually kind of just leave this alone after we set grid template rows, and those will flow automatically into new rows. But we want these new rows to be a specific height, so we can set grid auto rows to 12m. And I should take a second here to mention that we're using rows a lot, but but an analog feature exists also in the column direction. All right, so you may have noticed that in this example, I've been using some of the same images over and over again in slots of different aspect ratios, and they never seem to be distorting. And so how we do that is we tell each of these images to justify and align self to stretch. So basically what that does is it tells it to take up the entire slot, both height and width. And then the key item here is the object fit cover. So what that does is it tells the contents of the image element to expand itself proportionally so that it covers both dimensions of the image element without destroying its aspect ratio. And there are other values for this property too. Object fit and its cousin, object position, will also be shipped in October 2017 along with CSS Grid. So let's say that we have a particular item where we don't want it to stretch the entire slot. We can change this. So we can change this to, for example, align self center. And now you have this golden retriever that's centered vertically in its slot. And we can change that to self end, and now it's at the bottom of the slot. And as I mentioned, these also exist in the justify axis. All right, so one function that I actually enjoy is fit content. So you can think of this as kind of like being a max width within the grid notation. So let's say that we have a page here where we want the first column to be only as wide as necessary to fit the contents, but we don't want it to be any wider than 20 em. So how we do this is we set fit content and then 20 em within those parentheses. And so you can see when the headings here are narrow, there's only as much space as needed. But then when we add a heading that's really long, it gets wrapped to new rows after 20 em. So let's mix it all together. I've shown you guys quite a few practical examples to just kind of get through Grid today, but we can mix this together in surprising ways. So for example, we can make a collage area for one of the feature pages on a website. So this layout is using the same exact properties that I've shown you today and a z-index to stack items on top of each other. So the cool thing about using this approach versus position absolute, for example, is that everything takes up physical space within the layout. So this is a very responsive, friendly approach to doing this kind of layout. Lots of people are doing really cool stuff with CSS Grid. So you should check out Jen Simmons' Labs website. She's doing some awesome explorations with Grid and other layout techniques on there. Dudley Story has created this responsive periodic table of elements, which I just think is a really excellent and elegant use of CSS Grid. To explore CSS Grid, some people have been taking print layouts and kind of reimagining them on the web. So this is an example by Chen Hui Jing. And I think this is a really great way to explore if you're not really sure what you want to build. And finally, we can do some cool, creative, just kind of aesthetic things with CSS Grid. So this is a code pen by Liam J, and he's using CSS Grid with transforms and some really cool hover effects. So you should go ahead and check it out. There will be a link to my slides at the end if you'd like to look into these more. So with that, we've just kind of barely scratched the surface today because we have only had like a half an hour with each other. So you can learn more about this powerful feature at the Grid spec, so akms/grid-spec. And I encourage you also to check out Rachel Andrews' really excellent resource, gridbyexample.com. All right, so a couple questions come to mind when we talk about CSS Grid. So for example, what about browser support? I'm really excited to share that browsers have really rallied around this feature. Like, we know that we needed it, and we're really excited to ship it. So Microsoft Edge, we will have the new syntax, as I said, in October 2017, so next month. And Grid is also shipped in Chrome, Firefox, and Safari. We have the original prefix syntax supported in all versions of Microsoft Edge, including those going forward, and in IE10+. There are, however, a couple notable browsers without support, such as Opera Mini or UC Browser for Android. So I would encourage you to check out caniuse.com for more information on browser support. So what about this original grid syntax that I mentioned? So basically, since Microsoft proposed this, initially we had this initial vision, and much of those core, or all of those core features have made it into the new grid syntax. Some of them have kind of been renamed a little bit. But there are some new things in the new grid syntax, so just to keep aware of. And you can review these at the end because, again, there's a link to these slides. So you might be thinking, well, what about polyfills and fallbacks? So I understand how intimidating it can be to use something like a new feature for something as foundational as layout, because I come from client services where people expect everything to look the same in every browser version ever. But I would encourage you, instead of trying to use polyfills, to instead go forth and progressively enhance. So if you're not familiar with progressive enhancement, this is basically where we supply a basic functional, a nice experience for lower level browsers, and then as new features light up, we kind of enhance that experience. So when it comes to CSS Grid, we might use one of our more familiar layout tools to create a nice basic experience, and then make it magic with CSS Grid. So how we do this, we can target browsers that have support of CSS Grid by doing a support query at role. So that's just at supports display grid. We can also check for the old syntax, or the original syntax, using display -ms grid. That will only render in Microsoft Edge for that old syntax, though, however. So a lot of people have been embracing the support query, but some people are checking for browsers that support only the new syntax and not the original syntax. I'm here to tell you that this will only lead to sadness, because Microsoft Edge will be supporting both syntaxes for the time being for compat reasons. We don't want to break the web. We want to be responsible, so we're going to be supporting that original syntax. So this is all you need. At supports display grid. And it's fewer characters. Yay. So, all right, so you're listening to me and you're like, sure, I get it. Like, I'm on board with progressive enhancement, but how do I actually convince my clients and stakeholders to get on board as well? So there are some approaches we can take here, such as we can change up our deliverables. Often when we present static full design comps, it kind of gets the client or stakeholder in the thought that this is how the site is always going to look. So we can choose to show other things, such as style tiles. We can also write tiered support into our project statements for design. And we can kind of talk to our stakeholders and convince them that when we try to ship perfect design parity in every browser version ever, we might actually be creating a worse experience for people. We might be shipping crufty code or polyfills that are less performant than how the browser has designed different layout techniques. And we might instead choose a layout that we know is going to work pretty much everywhere, but it's kind of boring. This dog is bored with your layout. So one argument that speaks to quite a lot of people, understandably, is actually money. So if we want to support design parity everywhere, that's going to cost more dev hours, which means it's going to cost the stakeholder more money. And we know that when it comes to web performance, time is money, so shipping crufty code that's heavy and loads slowly, or polyfills that feel a little janky, that might not be the best idea. It's all about framing your argument for your particular audience and knowing what speaks to them. And I hope we can convince our stakeholders to embrace progressive enhancement and CSS Grid, because this feature is going to open up a wide new realm of web layout on our websites. And I can't wait to see what you do as you explore CSS Grid. Please, if you create something that you're proud of or think is cool, just at me, So Melanie Said, on Twitter. And if you'd like to learn more about CSS Grid, check out akms/summit-grid, where I have all the code demos and the resources listed here. All right, thank you so much, everybody.